A and B are independent events. It is further given that the probability of A and B is 0.3 and the probability of only B is 0.2. And then 12.1.1 says, are A and B mutually exclusive? Motivate your answer. Before we solve any problems, we need a Venn diagram, right? A Venn diagram just makes things more extremely easy. So the probability of only B, it is said to be 0.2. And then the probability of A and B is said to be 0.3. And then the probability of only A, we don't know it, right? So let's just put X here. And the probability of neither A and B, let's just put Y outside of our circles, right? 12.1.1 says, are A and B mutually exclusive? Motivate your answer. What do we mean when we say two events are mutually exclusive? Two events are mutually exclusive if they cannot occur at the same time. If you toss a coin, you cannot get tail or head simultaneously, right? So the events of getting head and getting a tail are mutually exclusive because they cannot occur at the same time. But then in our instance, the probability of A and B is 0.3. So they can occur at the same time, right? So they're not mutually exclusive. So the answer here will be no. And why are we saying no? The probability of A and B is not equals to 0. It is actually equals to 0.3. 12.1.2 says, determine the probability of only A. We have the probability of only B, probability of A and B, and then we're looking for the probability of only A or X on our Venn diagram, right? So from formula, we know that the probability of A and B is equals to the probability of A multiplied by the probability of B. So what is the probability of A and B? It is given to us, right? It's 0.3, and this is equals to the probability of A, which we don't know, right? But then after we found the probability of A, we're gonna be able to use it to find X, right? Because the probability of A will basically be this 0.3 here plus X, right? And then multiply by the probability of B. So let's look at B. The probability of B is 0.2 plus 0.3, right? So we're gonna have 0.5 here. So the probability of A will be equals to 0.3 divided by 0.5, which is equals to 0.6. So we have the probability of A now. We want the probability of only A. The probability of only A is this X here, right? So we're saying basically the probability of A is equals to the probability of only A plus the probability of A and B. You can see it on the diagram here that the probability of A will be the probability of only A plus the probability of A and B. So that will give us 0.6 is equals to probability of only A plus 0.3. You take 0.3 to the other side, you're gonna get the probability of only A being equals to 0.3. But then after you find the probability of A to be 0.6, you can just write your answer because it becomes obvious now that the answer will be 0.6 minus 0.3, but you can just solve it as well. And then now we want the probability of not A or not B. The probability of not X, right, is basically equals to 1 minus the probability of X, right? So now we're looking from the probability of not A or not B. So this will be equals to 1 minus the probability of A and B, right? In this instance, we're going to have the probability of not A or B or not B being equals to 1 minus probability of A and B. We know fully well what the probability of A and B is, right? Is this 0.3 here that I'm circling. So we're going to have 1 minus 0.3 being equals to 0.7. So the probability of not A or not B is 0.7, right? It will be the probability, it will be 1 minus the probability of A and B. Now let's move to 12.2. Says a teacher has 5 different poetry books. So let me just write here 5 poetry, and then 4 different dramas. So let me just say 4 drama, and then 3 novels. So let me just write 3 novels here. And then she must arrange these 12 books from left to right on a shelf. Fine. 12.2.1 says write down the probability that a novel will be the first book placed on the shelf. So she has these 12 books, right? She puts a blindfold on. What's the probability that she will pick a novel? She has 12 options, right? And of those 12, 3 are novels. So the probability of her picking a novel will be 3 divided by 12, right? And then 12.2.2 says calculate the number of different ways these 12 books can be placed on the shelf if any book can be placed in any position. So when she wants to pick the first book, right, she has 12 options. And then when she want to pick the second book, she has 11 options, right? And then the third, she has 10, and so on until she's only left with 1 book and she has 1 option of how she can arrange it, right? So basically the answer here, we have 12 factorial, right? Which will be equals to some number. You can just put that on your calculator. And then 12.2.3 says that calculate the probability that a poetry book is placed in the first position. The 3 novels are placed next to each other, and the drama is placed in the last position. Okay, so right, we've already established that if you want to peg all the books, you have 12 factorials, right? Because you have 12 positions, 12, 11, 10, going down until you're only left with 1 position, right? On our numerator, we're going to have the probability of the events we are interested in. The first case is placing a poetry book first. So how many poetry books we have? We have 5, right? So the probability here will be 5 because we have 5 poetry books. And then the next event says 3 novels are placed next to each other. So how can you place 3 novels next to each other? You can place them in 3 factorial ways, right? So we're going to have multiply by 3 factorial, because you can start with the first one, start with the second one or the third one, and then the second position, so on. So we have 3 factorial ways of putting 3 novel books. And then the next case says a drama is placed in the last position, right? So we have 4 drama books, right? And then we want the probability of placing them in the last position. The probability of placing the 4 drama books on the last position will be 4, right? So it's just the number of the drama books, just like the probability of placing a poetry was just the number of poetry books. So when we have placed this book, we still need to place the rest of the books, right? So in position number 1, we have placed is a drama. We have placed a poetry book, right? And then in position number 12, we have placed a drama book, right? So we have drama here. So we are left with 10 positions here, right? Of these 10 positions, we need 3 novels to be following each other, right? So we're going to be left with basically 7 positions plus a bundle of 3 novels that we need to be placed next to each other, right? So how can we fill these 8 positions that are left, right? We can fill this 8 position in 8 factorial ways. So here what's going to be left, let me just erase this, will be multiplied by 8 factorial. And then if you put that in your calculator, you're going to get your answer.